Hey folks, so like I mentioned at the end of class, I'm going to be doing a video solution for the wet toe. What I'm going to do though, instead of just coding the solution in front of you and explaining it to you, I'm going to go through the process that I expected you to go through. And I'm going to try and replicate some of the errors that I saw that people were posting about or asking me about in class. So that you can see, how you should be handling when you get certain types of errors, how you can look them up, how you can address them, especially when you're confronted with something as new as this, right? So none of you have probably seen stir F time before. And like I said, one of the goals of the wet toe was to have you go ahead, read documentation, understand documentation, look it up, get comfortable doing so. So you see on the screen, I have the description of the wet toe pulled up. So say I'm a student, I go ahead, I read through this, I get an idea of what it is that I'm doing, and really the only starting point I have based on this is checking out this documentation, right? I understand that I have to create a program that has a command line argument, and when I run that program, it's going to output the current date and time to a file, right? That is all the information I can get from this. So I don't know how to start, and I'm feeling a little stressed. I'm feeling a little roadblocked. So okay, let's go ahead and look at the documentation. So I pull this up and I'm like, oh my gosh, I've never seen anything like this. What is this? So one of the biggest things is actually reading what's on your screen, right? It's really easy to just skim it and kind of just want to look at the code and be done with it, but really understanding how a function works and getting comfortable using this reference page is going to be crucial. So I'm going to read it. So the way a reference page works like this, so those of you who've programmed in Java, you've probably seen Java docs, right? Especially those of you who took APCSA, for example. Java docs is big there, and even when you're taking the exam, you get documentation. If you've done Python, you probably haven't looked up documentation with Python because it's pretty explicit, which is why programmers like it, right? It's fairly easy to read. C++, and Java, they're a little clunkier, so they do have these reference pages that you can use to try and figure out what is what and what it does. So, okay, stir of time, it's telling me that it's a function. So, cool, it's a function. I know that far. That I understand. Size t stir f time, well, if I remember C++ syntax, this is going to be the output type of the function. So this function is going to return something of size t. Anything inside the parentheses are the parameters for the function, right? So just traditional function notation, which this is pretty standard across all programming languages. So it takes in a pointer to a character. It takes in something of type size t called max size, and then it takes in another pointer to a character, and that one's actually constant. It takes in a time struct, a pointer to a time struct that's also a constant. So I'm seeing things here that I haven't seen before, right? I'm not super sure what a size t is, and that comes up twice. And maybe I haven't seen struct time before. I don't think structs, you guys got through covering structs in 211. So again, the internet, your friend the internet, your friend the tool, this reference page, anything you need to know from here, you can look it up on here. So let's read what this does, right? So format time as string, copies into pointer. So it copies into pointer. So it copies something into this character pointer. The content of format, so format is this guy, expanding its format specifiers into the corresponding values that represent the time described in time pointer, with a limit of max size characters. Okay, that was a long sentence, so let me break it down. So it takes whatever is in here, right, the content of format, and it copies it into pointer. which makes sense, right? You have a pointer to a character, which is actually a C string, right? So hopefully you remember C strings. A C string is a string that is composed or created by having an array of characters in C++. You really can't pass actual arrays themselves around. You're working with pointers. So a pointer to a character is a pointer to a C string, which is a string that's just stored by individual characters in an array. And C strings are the default, essentially the default string in C++. So, okay, so it copies whatever is in format into pointer, and expanding its form specifiers into the corresponding values that represent the time described in time pointer. Okay, so based on this, right, and again, I am imagining that this is my first time looking at this. So time pointer, therefore, must be storing whatever representation of time is in C++. So that's stored here, and it looks at the format type, right? And then it translates this into this format to copy it into this with a limit of max size characters. So this just tells me how many characters I can copy over. Cool. So if, still struggling to understand this, can't break it down, we have here explanation of the arguments themselves and what they are, right? So PTR, I've been referring to it as pointer. Pointer to the destination array, there we go. It tells me that it's an array where the resulting C string is copied. Max size is the maximum number of characters to be copied into pointer, including the terminating null character. With C strings, you have the entirety of the word. So let's say I'm storing the word Bob in a C string. My array is going to be a size 4. It's going to store the B, it's going to store the O, it's going to store the B, and then it's going to store a null character so that C++ knows when it's going through that array, through that C string, that, hey, this is the end of this array. This is the end of this word. So it's all, the size of any C string is always going to be however many characters the word is plus 1, because it's storing that null character. If you are curious to know what a null character looks like, it looks like \O or \0. So if you remember to do an enter space, right? So we do these escape sequences to represent different types of characters. So \n is a null line character, \0 is a null terminating character, or null character usually used to demonstrate something terminating. Okay, format. It's the C string containing any combination of regular characters and special format specifiers. These format specifiers are replaced by the function to the corresponding values to represent the time specified in time pointer. They all begin with a percentage sign and are, and then there's this huge table. So it tells me what the specifier is. It tells me what it's replaced by, right? So when I put a %G into that format argument, it's going to tell me the week base year, and it gives you that example, right? Because, what even is a week base year? Oh, well, it's the 4-digit year. Got it. That makes sense. Okay, cool. So it tells me specifiers mark their are locale dependent. Okay. Don't think I care about that just yet. Okay, that's fine. Time pointer to a TM structure that contains a calendar time broken down into its components. See struct TM. Cool. Yeah. What is the struct TM? I don't really know what this is. It's a structure containing a calendar date and time broken down into its components. Okay, cool. So it's just a type, right? So when we think of types, we think of double, float, int, string, C string. This is just another type, a struct TM, and like I thought, it stores time, the date and time in the format that C++ expects. So cool, got that. All right, so return value, right? So we saw that it returns a size T type. So what is it returning? If the length of the resulting C string, including the terminating null character, doesn't exceed max size, right? So if your function works, or if your function call is able to execute properly, the function returns the total number of characters copied to pointer, not including the terminating null character. Otherwise, it returns 0, and the contents of the array pointed by pointer are indeterminate. Okay, cool. Well, I don't think I'm going to be doing error checking for this, right? I mean, we know if we look at the slides, I know exactly how many characters, or like the maximum number of characters that this is going to take. So, you know, I'm pretty short on time. Don't need. I'm not. You know, if I can get to the error checking, then I'll do the error checking. But for now, I don't really care what this returns. So let's see at this example. Okay, so we have the header files that are being included. We've got our main function. Okay, so we create a variable called raw time of time t. Let's see where that's used. That's used down here. So something that's really helpful when you're looking at code, especially with examples, is to, instead of going to it line by line, is if you don't know what something is, right? So if you've never seen something of type time t, figure out where it's getting used and look up what that type is, right? Or, for example, in my case, you know, the term seems pretty descriptive, excuse me. You know, a time t, right? So if we're storing things in a struct tm, seems like the raw time based on this variable is stored, this time t is the format that C++ recognizes time in. Cool. But I want to see where it's getting used. So I look for raw time, and it's used here, this function time. And I know it's a function call because it's a word, and then there's parentheses and a semicolon, right? So that is a statement, and in order for the statement to run, since it's not getting set to anything, right? It's not time equals, it's saying time parenthesis, then I know that this is a function call. So if I want to know what time is, I can look that up above. And then I see that it's used here again. Notice that it's used with the ampersand, right? So that is telling me that it's a pointer that's being used. So now we have this time info here, and that is getting set to local time, whatever the result of local time is, after you've passed in this raw time. So what is time info? I go back up, and I see this, and here we see the struct tm again, right? So time info is a pointer to a struct tm type, right? So the star tells me that it's a pointer. So, okay, I feel like I sort of understand that. I'll probably want to look these up in just a minute. Let's see, we have a character array of size 80, and we're calling that buffer. Cool, I know what an array is, I know what a character is, I know how to initialize an array, so I know that this is a character array of size 80. Awesome sauce. So let's look at what these guys do, right? What does time do? What does local time do? So I'll go up here, I'll look up time, open it in a new page. So the function time gets the current time. Wow, look at that. That makes sense. The function returns this value, and if the argument is not a null pointer, it also sets this value to the object pointed to by timer. Okay, so when this function is being called down here, when you're calling time, you know, you're not setting it equal to anything, right? It's returning a value, but you're not setting it equal to anything. But what it is doing is it's storing the current time into this raw time t type variable, right? Because we gave it a pointer, so it goes ahead, it finds it, and it says, hey, you're going to become the current time. All right, so what does local time do? So I know what time does. Time finds the current time. And it tells me this value return journey represents seconds in 00 hours, Jan 1st, 1970 UTC, the Unix timestamp. Okay, so it's going to give me UTC time, which probably not super helpful unless you know exactly how many plus or minus hours we're from UTC time. So let me look up local time. Based on what I'm seeing here, I'm going to assume that local time takes time from Unix time and converts it to whatever your locale is. Uses the value pointed by timer. So timer is a pointer to a time t. To fill a TM structure with values that represent the corresponding time expressed for the local time zone. Got it? So, you know, like I intuitively figured out, it just sets the time to the local time zone, right? So we're in Eastern time, for example. So this line gets the actual current time in UTC, and then this converts it to local time. So we see that we get time info posted to that. So let's check. So it returns a pointer to a TM structure with its members filled with the values that correspond to the local time representation of timer. So this is important, right? So with time, the function that we looked at previously, it changes the pointer, the value of whatever the pointer is pointing at, to hold the current time. This one returns the updated time, right? So that's important to note, right? So raw time no longer has the time that we want. The time that we want is now going to be stored in time info. Okay, so now we do stir of time, which is what started this whole thing, right? Like we're looking at this just to figure out what stir of time is doing. Okay, so like the parameters up here said, right? So just as a reminder, you've got pointer, max size, format, and time pointer. Okay, so you give it the buffer. So this is where this character buffer is where this info, time info, is going to be stored in this format. So if you take this, combine it with this, it's going to store it here up to size 80, right? And where are we getting that 80? That was an arbitrary number that was chosen because we, based on this, we're going to have more than plenty space to fit all the characters that we need. And if we look at ours, you could go ahead and count the characters manually, figure out which is the longest month that you can possibly have, and figure out how many exact characters you need. But for the sake of purposes, again, we're short on time. We have 20 minutes, 25 minutes to do this. Cool. We're going to work with 80. And then puts is called on buffer, and it says example output. So what is puts? What does that do? So let's look up puts. Write string to standard out. Writes the C string pointed by stir to the standard output. Okay, so it takes whatever's in buffer and it prints it. We don't want to do that. We want to write to a file, right? So one of the other nice things about the C++ reference is that at the bottom, it gives you things that you might be interested in, right? It's kind of like when you're shopping on Amazon, it says, you're looking at this item, you might be also interested in these other things. So it gives us these 4 things here: fputs, printf, putchar, and gets. So let's see. Fputs writes string to stream, printf print formatted data to standard out. So again, standard out, don't care for. Write character to standard out, don't care for, it's standard out. Get string from standard in, don't care, we're not getting anything from standard in. So, fputs looks promising. Writes the C string pointed by stir to the stream. Okay, stream, maybe I don't remember what a stream is, maybe I don't know what a stream is. We see here that it's a file, right? It's of type file. It's a pointer to a file. That looks like exactly what we're trying to do. So let's start slow, right? So can we get this to work? So I'm going to go ahead and pull up my code. And this is one of those things where, is it plagiarism because I'm copying? I just spent, I don't even know how many minutes really going into the code and understanding what it's doing, right? There is not much that I can change from what I have here to do what this problem is asking me to do, right? Like this is setting up variables and getting the local time and then formatting it into the format that I want. So is this something that I can copy paste? Yes, yes it is. So go ahead and put that into my code. You'll see that I am old school. I like using just a regular text editor. I'm not a fan of IDEs. You probably have an IDE. And, just because I know that I spent a lot of time looking into this, and I know that if I come back to this and I don't have comments, I'm not going to know what I did. So I'm going to go ahead, let me save this so it can color code it for me. Let me call this main.cpp, and I actually have another file called main, so I'm going to call it main2. So we said that raw time stores the raw time in UTC from function called to time. And we said that this guy, or actually, you know what? I'm not going to say stores because it doesn't store it just yet, but going to store. This guy, we said time info. So time info is going to hold actual time we want. And this is going to hold the formatted version of time info. Okay, so we set time, so this gets raw time, or not raw time, that doesn't make sense, UTC time, and puts it in raw time, takes UTC time stored in raw time, converts it to local time, and stores it in time info. So long comment. All right, so stir of time now takes time in time info, formats according to third argument, right? So that's this third argument. Stores it in buffer for a max of 80 characters. And then we said that this prints contents of buffer into standard out. Okay, so have my comments. So that'll help me as I'm debugging this. So we go back to the problem. Ooh, current date and time, February. Okay, so there's no period. I'm just gonna start over. So we want current date and time, and then we have it on a new line, and then we want the month in the full month. So let's see. It's easier for me. It's just easier to look at the example, right? I see where is there an example of full month. So full month name is going to be a %B. So I'll do %B. So February space, then I want the date. So this looks like a date, but that's the year. This looks like the date. The other month 0 padded. The other month space padded. Hour, Okay, so let's see. Do we want 0 padded? No, it says just 5. So I want this guy. And if it's space padded, then that means, you know, it's adding the space for me, so I can get rid of the space I have there. So that's a %E. %E. And then it'll be comma and the 4-digit year. So 4-digit year we saw it earlier, %G. Okay, and then we have a new line, and then it was the actual time. And so to get the time, it was hour and 12-hour format, so that's a %I. So we've got %I, then going to be the colon, we want the minutes, minutes, %M, and then to confirm, there's a space, and then it says PM. So PM is %lowercase p. Okay, so let's see if it's printing what I wanted to print before I start dealing with the file. So, like, full disclosure, I like this isn't muscle memory for me either. So we again can copy paste that function and what's in your memory, your command line memory. You can do it from there. So let's see, where am I? So I need to find where my file is. So I'm going to go into my downloads. Okay. So I gotta remember that I actually named my file main2. Cool, no errors. So let's run it. Hey, look at that. Looks like we're actually missing the space there. So it said space padded, but it didn't add the space that I wanted for the 29. So that's an easy quick fix. Add a space there. I'll save it. Recompile, run it again. Current date and time, January 29, 2021, 6:36 p.m. Awesome. Look at that progress. All right, so what's next? So I have the date and time, and what I want to do now is I want to get it to print to a file. So we were looking at this guy that takes a C string and prints it to a stream. So let's see how it's used. So you have a pointer to a file type. They have this array. Enter sentence to append, f gets, sentence 256 standard in. Okay, so this looks like it's using standard in, so I don't think I want to do this part, but let's see later on. So p file, f open, it opens the file. There's a random a there. I don't know what that means. F put, so that's the actual function call. It takes in sentence, which is a character buffer, a character array, excuse me, and the file, and then it closes the file. So let's see what a fgets does. Is that something that I care about? So get string from stream. Right, so I didn't even have to go up and look it up. It's down here, and it gives me the TLDR version of the docs. So get string from stream. I'm not doing that. I don't care about getting anything from stream, right? I'm not reading from a file. I'm not reading from standard in. So don't care for that. But I do care for the other stuff that's happening, right? I don't care about this because I'm not printing, and I don't care for this because I'm not going to read from standard in, so I'm not going to use sentence. But what I am going to use, right, so what is the thing that I'm trying to print? So I'm trying to print buffer. So let's see. We'll start with, baby steps. So we have a file. I'm just going to call it file. And then, what's important to remember? Actually, I'll pretend like I forgot the time. So we have, a thing that's really important to check is make sure that you're including the header that you need to call that function. It just so happens that fgets is already part of, or fputs is part of studio.h already, along with regular puts. So puts and fputs are part of the same library. So I wouldn't have gotten an error there, but if I had forgotten to include that, that would not have been fun. So, okay, so we create the file. Like I said, I'm not going to use this because I'm using buffer. I do fget, and let's see. So this has, oh, nope, not doing fgets, right? Because we said that gets input from the stream, so don't need that. So I need to do fopen. I see this thing though. I don't know what this is. So let me look up what fopen does. And since I'm done with stirf time, like I can get rid of that tab. So let's look up fopen or fopen. So it opens a file whose name is specified in the parameter file name and associates it with a stream that can be identified in future operations by the file pointer return. Okay, so it opens a file. Makes sense. What is that A though? This car mode or char mode. So mode, C string containing a file access mode. It can be read, write, append, read, update, write, update, append, update. Okay, so I'm not appending, which is what that example had. I'm only writing. Create an empty file for output operations. If a file with the same name already exists, its contents are discarded and the file is treated as a new empty file. Perfect, that looks like what I want. So let's go back here. So it had file, let's remember the docs. So the file you open with the syntax. So file equals fopen. Then, oh, that is what my command argument is going to be. So let's see, I remember that the command line argument, the 0th thing, is going to be whatever the name of the program is. And so I'm going to want 1, right? And then I realize, oh, I don't even have that up here. So I will get to that in just a moment. And the second argument was, oh, that's my W. All right, because I only want to write. And then let's see, we do puts and then close. Okay, so f puts, and we want to put the buffer into the file. And then we're going to do f close, and if you don't know what that does, you can always look it up. So whenever you open a file, you want to close a file. That way your computer knows, hey, this file is no longer being in use, and you don't have what we call memory leaks. So closes the file associated with the stream and disassociates. Cool. That makes sense, right? If you open the door to something, you want to leave it closed. So you're going to f close the file. And cool, we're done. So got to remember, our argvs are currently not here. So let's say I don't remember how to do this. I'm like, oh, I know there's some stuff that goes there, but I don't remember. You know where it is? In our deep dive, because the deep dive has us do command line arguments. So let me do command line arguments. What's a command line? What's a command line? Command line tool, command line arguments. If you haven't created tools for command lines, you need a refresher. Please read this tutorial or watch this video. I don't feel like watching a video right now, so let me look at this tutorial. I just need a refresher. To pass command line arguments, we duplicate the file with 2 arguments. First file argument is the number of command line arguments, and the second is list of command line arguments. Okay, got it. So I can use this or this, doesn't matter. And just refresh me on this. So this is an int, right? Like that's a type of int. But what is this? Why can I use both? Why can I use a star argv bracket bracket or a star star argv? Argv is a vector of character pointers listing all of the arguments. It's an array of character pointers listing all of the arguments. So character pointers, as we learned, hopefully, are C strings. So this is an array of C strings. So it's an array, right? So that's where this bracket is coming from, of C strings. So a car pointer is a C string. Cool, that makes sense. What is this? So it's an array of pointers to pointers. Okay, pointers, arrays in C++ are pointers, right? Whenever you're passing through an array, you're actually passing a pointer to the memory location of the first index of that array, the 0th index. So when I pass an array, I'm passing a pointer to the array, then it makes sense that the syntax is this, because now I'm saying it's a pointer to a pointer. It's confusing. It's a pointer, so it's a thing that's pointing to more pointers, right? So it's an array of character pointers. Arrays, when we pass around arrays, we're dealing with pointers. So that's why we have this double asterisk here. I feel like I'm going to forget that. So I'm going to use this so that I remember later on that I'm dealing with an array of character stars, just in case I forget that weird star syntax, because I'm not used to seeing that. So I'll paste that in there. Oop. So this is an int argc, Okay, so this looks good. This looks pretty solid. Excuse me. Let me add in a couple comments here. So opens file, puts contents of buffer into file, closes file. Okay. So let's run this again. Awesome. and or compile it, excuse me, and let's run it. Can we still print it out? I don't want to do that. So let me get rid of this. Compile it again. Got a seg. Oh, forgot to give it the file. Okay. So prog, and I'm gonna call the sample out.txt. Okay, so it gave me a seg file. I don't even know what that means, but you probably haven't learned about seg faults. It means you tried to access something that you didn't have permission to. But you realize, oh shoot, I forgot the command line argument. So there's my command line argument. So let's go ahead and look at my sample out. Cool. That looks like it's in working condition. So let's go ahead and submit to our Autograder. And one of the things that I have to do is I have to rename this main.cpp because I have to, also this looks different because I'm not a student, but I have to rename my main.cpp so that it can run it. So let me go here, and I have already a main.cpp that I don't actually want to delete. So let me move that to, and hopefully you remember from move that this is how you can rename files. So I moved my original main CPP to main3.cpp, and the file that I'm currently working with, which was originally called main2.cpp, I'm renaming to main.cpp. Okay, cool. So we have my main.cpp, I upload it. Okay, gotta wait for it to run. The hell? This was working, right? I got tons of emails like this, what is happening? My output matches. First line formatting, demonstrated understanding, proper day and time format, demonstrating competence. Well, that's weird. I mean, the first line, right? Tell me that something is wrong with the first line, but it says current date and time here, and it says current date and time here. Wait a second. Current date and time, current date and, I have an extra space. All right, let me go back here. Let me get rid of this. Let me save this as main.cpp. Yes, I want to replace you. No, I don't want to buy you. And let's go back. So you would click resubmit. I can't do that, so I'll do it this way. So I'll do a main.cpp and I will upload. Success! Awesome. So finish the problem. Now, if you feel comfortable with functions and abstracting your code out, you can stop watching this video. If you would like to know how you would abstract this code out, definitely recommend you continue watching. Actually, recommend everyone continues watching because a lot of folks just give me a big thing of code like this. And when you try to abstract out, this is where things can get tricky. Because you're dealing with pointers and moving those things around, you end up getting some funky errors. So some of the errors that people got were due to trying to abstract things out. So let's say, okay, well, I have two distinct things happening here, right? I'm getting the time, and then I'm printing the time to a file. So that seems like two disjointed things. So what I want to do is I'm going to create two functions. Now, when I do this time, you got to think about, right? So for this function, do I need to return anything? Well, the information that I want, it's going to be stored in buffer. So I need to return buffer so that I can then pass that into my next function, which is going to print what's in buffer to the file. So buffer is a character array. So I will say car, and array. Those of you who know what the error is are probably cringing. So carre get cur day time. Oop. And does it take any arguments? No, it does not, right? Because it's not asking for any information from anyone. So I'm gonna go ahead and just take this, move it up here. Wow. Indentation. Geez. So the other really nice thing about Sublime is you can do this. You can do multiple cursors, which is a lifesaver. Okay, so a good programming practice is to not do too many changes at once, because if something breaks, you're not going to know what broke. So in theory, right, this should work, right? All I did was, why is this indentation off? All I did was stick the code that I had before into a function, and now I can use that function to do what I was doing here before. So we have a car buffer equals, and that gets returned, so character current time. Okay. Oh, and it's a function, so I need my parentheses, and then buffer gets passed around. Okay, so that should work. Let's see. Okay, remember I renamed this. Whew, okay, did not like that. Brackets are not allowed here. To declare an array, place the brackets over the name. Function cannot return array type car bracket. Okay, give me 2 errors. Let's address the first one. So it's telling me to put it after. So, okay, I will just move it over. Okay, C++. Function cannot return array type car bracket. Can't return arrays. Well, that's what? Let's see. Let's see what Google has to say. So I'm going to copy this error message. You can't really return an array from a function, but a pointer. Okay, so this person's trying to return an int array. They're telling them to return an int pointer. Okay, well, let's see. If I'm trying to remember how arrays work in C++, arrays, yeah, so when you have a variable to an array, you actually have a pointer to the first element in the array. So that, okay, I guess that makes sense. I think I might need to like reformat some stuff for this to work, but let's see. So I can't return an array, but I can return a pointer to an array. Okay, so let's see what happens there. I wonder if this is going to work. Let's see. Yeah, no, I thought it's a non-void function. Non-void function. Oh, I'm not even returning what I need to return. Okay, that error I understand. Array initializer must be an initializer list or string literal. Okay, I don't know what that means, but you know, it felt weird leaving leaving this like this, right? Because this is a character pointer, so presumably this would also be a character pointer, right? We have to make sure that our types match. Okay, so let's try this. Address the stack memory associated with local variable buffer returned. Address the stack memory associated with local variable buffer returned. Huh. Okay. Not really sure what that means. So let's go back to our old friend, the internet. Declare will be automatic. When you turn matches, memories for matches will be freed, and your pointer will point to something that you don't want to. Static. How that feels wrong. I should be doing memory allocation for this. Huh. Okay. Well, that doesn't help. Lots of memory allocation stuff here. That feels like overkill. Okay, so I'm seeing the same things over and over. So it's creating this local variable. And then it's returning that. Okay, so let me go back to that static thing. It said something about making the static. Because I don't feel like dealing with memory allocation right now. So declare matches as static. This will allocate space for matches in the static space and not on the stack. This may be okay. So what does that mean? So CPP is static. Okay, when a variable is declared as static, space for it gets allocated for the lifetime of the program. Even if the function is called multiple times, space for the static variable is allocated only once, and the value of the variable in the first gets carried to the next function call. Well, that sounds like what I want to do, right? I mean, I have my buffer array, and that's what I'm going to be using later down the line. So yeah, I only want one buffer array, and I want it to exist for the whole program, even if I'm abstracting it out into different functions. So let's go ahead and do that. Okay, and let's see if it stops yelling at me. Okay, nice. Oh, forgot the file again. Sample out.txt. Let's see what this looks like. Cool, that still works. Awesome, so I have one function down. So, excuse me, let's do function 2. So for this function, I'm going to take all of this and stick it in there. So this is going to, is it returning anything? No, it's writing to a file. That's going to be a void. Write to file. I'm going to take this and we'll fix that at a later time. Okay, so I'm gonna run with this. argv here doesn't exist, so we need to pass that in. All right, so I don't remember what argv type is, so let me look back at that documentation. Where was this? Puts. So that is it's the file stream? It's the first argument. So the first, oh no, that's fopen. That's what I wanted to look at. Okay, so fopen. Let's go over here. It's a constar file name. Okay, so it's a constant C string. Okay, so const car star is going to be the file name. And then I'm going to use file name here and save that. And then I'm going to go down here. Let me just hide my face so that we can see all of this. Okay, so we're going to go down here and we are going to, oh, you know what else I need? I need the buffer. Okay, so the buffer we said is a car star. I'm just going to call it buffer so that I don't have to change this here. Car star buffer. So we have file name, we have our buffer. Okay, so now I should be able to call right to file. I like copying and pasting my function name so that I make sure I don't mistype anything. And then the file name, so here we're going to do argv1 again, and then we're going to give it the buffer that we just created. Okay, so that looks reasonable to me. Let's run this. Okay. All right, it ran. Cool. Looks like it's still working. Let's see what the Autograder has to say about this. Where are you? You're over here. So again, for you, you would click resubmit. I do not have that. Okay, it's running. Cool, it still passed, and now I have some code that is abstracted out. It's nice and clean. I have my comments. Awesome. I think this is as good as that's gonna get. All right, yeah, so I hope that this was helpful. I know it was a bit of a long video, it was longer than I was expecting it to be, but hopefully seeing how, you know, one would go about this. You know, I know that we definitely didn't have enough time in class to get through all of it. As you saw, right, I was doing a lot of the explaining, a lot of the searching up, a lot of the error watching and error checking. And so that does take time, but I wanted you all to, you know, hopefully get to at least the part where you had the functional code, and you know this abstracting part can come later. So hopefully that was helpful in terms of not only figuring out how to code this, but figuring out how to approach a problem, right? When you don't have, when you don't know where to start and you're giving documentation and, you know, looking at those examples, that's always super, super helpful. So hopefully the strategy of this, the strategy of this video you find helpful and you can use it in future programming assignments. And yeah, if you have any questions, post on Piazza. Otherwise, I will see y'all on Tuesday.